Hello students, today I will be giving you three basic numericals regarding the chapter electric field and charges that we have finished. So the first numerical is that you can see over here that there are two charges Q1 and Q2 each having charge of 6.5 into 10 to the power minus 7 coulomb. What is R? R is the distance between the charges. It is given how much? 50 centimeter. So we must convert into meter. It will be 0.50 meter. We need to find the force between those charges when they are placed in air. So I think we have only one law to find the force between two charges, that is Coulomb's law of electrostatic. That formula is what? 1 by 4 pi epsilon naught q1 q2 by r square. So that formula we are only using here. So 1 by 4 pi epsilon naught, it is epsilon naught because it is air over here. What is epsilon naught? It is the permittivity of the free space. So the value of 1 by 4 pi epsilon naught, we know that it is 9 into 10 to the power 9, and q1 and q2 both charges are same, so we can go for square of the charge, 6.5 into 10 to the power minus 7 whole square, and the distance is given how much? 0.50 square. Okay, so the force become how much? After calculating all this, the force will be 1.5 into 10 to the power minus 2 Newton. Okay. Now the same question has the next part. When the charges, what will happen to the force when the both charges gets doubled and the distance between them is halved? Okay. So you can see over here, F air again 1 by 4 pi epsilon naught, as the both charges have been doubled. So 2q1 into 2q2 in the denominator, in the place of charges which were earlier q1 and q2, now it will be 2q1 and 2q2. Okay, and the distance between them is halved, so it will be r by 2 whole square. So we know that 2 into 2 is what? 4 q1 q2, and the square of r by 2 is what? R square by 4. The 4 in the bottom will go to the numerator, it will be multiplied by the 4 over there, and it become how much? 16. 16 into 1 by 4 pi epsilon naught q1 q2 by r square. Again you can see over here that it is 1 by 4 pi epsilon naught q1 q2 by r square, the value of which we have already calculated in the first part. Over here it was how much? 1.5 into 10 to the power minus 2 Newton. So only we need to place the value over there, no need to find it again, and we will multiply it by 16. How much we will get? It will get 0.24 Newton. Second part over. One more part is there. What will be the force acting between the same two charges having same distance between them if they are placed not in air but in water? Okay, so I think we know it better. Remember when we were finding dielectric constant or relative permittivity, it was the ratio of force in air to the force in medium between the two charges when placed for the same distance. So here force in air we have already calculated. The value of K, that is dielectric constant of water, is given 80. So we need to find what? The force when placed in water, that is medium. So from that formula only we can find F medium equals to what? F air by K, that is dielectric constant. F air we have already found 1.5 into 10 to the power minus 2 divided by 80, that is the dielectric constant, and you will get the value as 1.9 into 10 to the power minus 4 Newton. This is the value of the force when the same charges are placed for the same distance, not in air but in water. So in this one numerical only we did a 3 types of numerical. On the next question, you can see the diagram over here. 3 charges are there, Q, Q and minus Q. You can see that the magnitude of all the charges are same, but the first 2 charges are positive and the last charge is what? Negative charge. They are placed at the vertices of an equilateral triangle. Find the force on each charge. So basically you need to find the force on each charge. How you are going to find it? First let's go for the diagram only. You can see there are 3 points A, B and C of the triangle. In the place at point A we have placed charge Q, point B again Q, and point C minus Q. As it is equilateral triangle, let the length of any side is L. So all the sides will be L only, L, L and L. First start with the charge which is at point A. The charge which is at point A is plus Q, and the charge which is at point B is also plus Q. So there will be a force of repulsion. You can see on the left hand side is a force F, but the charge on C is minus Q, on the charge on A is plus Q. So there will be a force of attraction. You can see a charge along the direction, force along the direction AC. Okay, these two forces are giving us what? The two arms of a parallelogram. So the resultant will be coming by their diagonal, which is given by F1 in the diagram over here. Okay. Similarly, on the point B also, you can see there are two forces, one because of repulsive force of A and one because of attractive force of C. Again, these are forming the two adjacent sides of a parallelogram. So the resultant will be given by their diagonal, that is F2. Okay. Again, on the point, now coming on the point C. On the point C, the charge is what? Minus Q, and the other charges which is placed at the bottom are both plus Q. Okay. So both the forces which will be acting on the charge C will be attractive in nature. Okay. They will attract the charge on C towards each other. Again, they will form the two adjacent sides of a parallelogram, and the diagonal will give the resultant, that is F3. So there are three forces. Now if you want to find force, how you are going to find it? By using parallelogram law. And we know that the formula of resultant in the parallelogram is what? Under root A square plus B square plus 2AB cos theta. What is the theta over here? The angle between the two forces. If we suppose first we are going for the force on charge A, that is F1. You can see over here the angle between them is how much? The two charges is what? 120 degree, because it is an equilateral triangle. The internal angle is 60. So what is the value of external angle? 120 degree only. By putting this, we can find the value of the force. It is under root F square plus 2 FF cos 120. So why F square? Because what was the formula? Under root A square plus B square plus 2AB cos theta. But here A and B both are same, that is F only. Okay. And why they are same? Because the distance between all the charges are same, because it is an equilateral triangle. Again, the force on charge Q2 will also be F only. You can calculate it by yourself. Now coming on the force on the charge C. As you can see, the angle between the two charges on C is 60 degree, because this angle is the equilateral angle of an equilateral triangle. This is 60 degree only. Okay. In the earlier two forces or the charges, the angle between the two charges or forces were 120. But here in this case, the angle between the two forces is not 120, it is 60 degree, because it is the angle between the two forces in an equilateral triangle. After putting all this, you will get the value how much? Root 3 F. Second numerical. Now third numerical is very easy, based on the dipole question, that a dipole is placed along the axis. You can see there are two charges, plus minus 10 microcoulomb. Okay. And microcoulomb, we know that the value of 1 micro is 10 to the power minus 6. Okay. The distance between them is given, that is 2A is 5 millimeter. We can convert into meter by multiplying it by 10 to the power minus 3. We need to find the value of electric field at a distance of 15 centimeter, that is 0.15 meter from the center of the dipole on the axial point line. So how we are going to find it? We have a formula, I think we have already studied it. 1 by 4 pi epsilon naught 2p by rq. What is p over here? P is the dipole moment, that we can find by multiplying the charge of the dipole by the distance between the two charges. after putting all these values